Welcome to this Revit 2016 project. In this series of videos, I want to show how I modeled this industrial foundation in Revit 2016. Traditionally, industrial foundations such as this have not been modeled. Instead, they have been drafted using CAD programs such as AutoCAD and MicroStation. One of my objectives in making these videos is to highlight the differences between drafting and modeling. This foundation was originally drafted using AutoCAD. Modeling in Revit, a foundation that had originally been drafted with AutoCAD, makes it possible to compare the two methods of producing construction information. In this Revit model, the following have been changed in order to protect proprietary design information. This foundation supports two furnaces. Furnace number 1 sits on the circular foundation, and furnace number 2 is located here. To document this foundation, I created 500 views and 200 schedules of quantities. I then placed these views and schedules onto a total of 150 Revit sheets. The final package includes all the information needed to construct this foundation. The package includes rebar placing drawings, rebar schedules, rebar totals by diameter, concrete volume, area of steel deck, bill of material for steel deck support beams, and a bill of material for anchor rods. All the drawings for this foundation were drafted with AutoCAD in a 2D format. Drafting is a laborious process of drawing plans and sections line by line and then annotating them with manually typed descriptions. When CAD arrived in the 1980s, this same drafting process was implemented on a computer. CAD programs such as AutoCAD and MicroStation are simply pencil and paper drafting on a computer. That's all they are. An AutoCAD drawing is simply a collection of lines and geometric shapes. What these lines and geometric shapes represent is unknown to AutoCAD. Drafting always involves duplication of information. One of the piers on this foundation is shown 19 times on a total of 17 drawings. If the basic geometry of this pier were changed, each copy would have to be modified one by one. Modeling is the placement of 3D representations of real-world objects. This model consists of slabs, walls, columns, steel beams, steel deck, rebar, and anchor rods. The model is documented by taking views of the model, then annotating the views with dimensions and tags. An object can appear in many views and be tagged in each view without any of the duplication that plagues projects drafted in AutoCAD. If the properties of an object in the model are changed, then all the views that show that object are instantly updated, as are all the tags that display the properties of the object. An important point to make is that a Revit sheet is not the equivalent of an AutoCAD drawing. An AutoCAD drawing is expensive to create, and a set of AutoCAD drawings are expensive to manage. A Revit sheet is cheap to produce, and managing a set of Revit sheets is much simpler than managing a set of AutoCAD drawings. The AutoCAD version of this foundation had about 60 drawings, with some rebar schedules. My Revit version has 150 sheets. Producing 150 sheets in Revit takes fewer hours than producing 60 drawings in AutoCAD. And remember, the Revit version includes all the quantities. The way a drafting project is undertaken is strongly influenced by the limitations inherent in the entire drafting process. The cost of drawing plans and sections line by line, annotating them manually, and then having to devote more resources to review this manual process for errors has led those responsible for the drafting of the project to insist on minimizing the number of plans and sections so as to minimize the number of drawings, even as this has made the project harder to follow. Without the limitations of the drafting process, a Revit project can be approached with a fresh perspective. In this project, Revit 2016 can replace AutoCAD almost completely. The only exception would be details of anchor bolts and beam connections. For these details, I would use AutoCAD. Using Revit does require a new approach to documenting a construction project such as this. Many former practices were determined by the limitations of drafting. These limitations go all the way back to the age of pencil and paper. The arrival of CAD made drawing lines and making changes easier, but it didn't change much else. CAD, after all, stands for Computer Assisted Drafting. These are the features of Revit that I believe require a new approach to documenting construction information. The display of the structural components of this Revit model is determined by a set of rule-based filters. Rule-based filters enable the display of a structural member to be dependent on the properties of the structural member. In this series of views, the display of the piers and walls is determined by the top of concrete elevation of each. Items with the same top of concrete elevation are displayed in the same color. The building piers on this foundation have two different tops of concrete. In Revit, changing the concrete elevation of a column or a pier is simply a matter of changing the top level property of the column in the Properties palette. Revit will then update the column in the model. All the views that show the column will be updated, and the color of the column will change to reflect the new value of the top level. In AutoCAD, all these changes would have to be done manually. These four views show the model without the top slab, as two different view templates are applied to the view. In Revit, a view template is a collection of parameters, including filters, that control the display of the components of the model. A view template is changed in the Properties palette of the view. A Revit view is so simple to create that there's no reason to limit their number. In this Revit project, I have used three types of views: traditional plans and sections, and also Revit section boxes. A Revit section box is a way to create a non-orthogonal view of a component of the model together with the adjacent components. A section box is very simple to create. A Revit view is radically different from a traditional CAD plan or section. A drafting section, whether drawn on paper or drawn in a CAD program such as AutoCAD, is a driving parameter. A Revit view, on the other hand, is a reporting parameter. A Revit view is a view of the model. The view reports what the model looks like from that particular viewpoint. A Revit view cannot be incorrect. The model may be incorrect, but not the view. In drafting, whether on paper or in CAD, there is no model. In drafting, plans and sections are what the drafter believes the model would look like if there were a model. As a result, drafting plans and sections can be incorrect and must be reviewed for errors. One of the basic skills of drafting is this ability to create plans and sections in the absence of a model. This skill, I believe, is becoming obsolete. Here is one of the sections I displayed earlier, and this section really did take just 3 minutes to create. So the next step is to tag the objects in this view. Now, tags can completely replace the manual labeling of structural members in the model. So to tag an object, the first step is to type on the keyboard TG. Now some of these piers have shear slots, so I'll tag one of those. I can also tag the top of concrete of the pier. I go to the keyboard and type EL. And there it is, top of concrete. Now I'll tag the rebar. Now I'll tag the ties in the tie beam. There we are. Here is the finished view. Every annotation on this view is a tag. Nothing was typed. In the AutoCAD version, this section was drawn line by line. Every piece of text on the section was typed manually, and that includes the column grid line text. Here's a closer look at the view and the tags. As I mentioned earlier, duplication is a big problem with CAD. In the AutoCAD version of this project, some of these footings are shown 5 times and appear on multiple drawings. In AutoCAD, each appearance of the footing is a copy of the footing, and each copy of the footing has to be checked for consistency. If the footing is revised, then every copy of the footing has to be reviewed and revised accordingly. Then, once again, the revisions have to be reviewed for consistency. And so it goes on. In the Revit version of this project, this problem does not exist. These views show the same footings and piers. In the AutoCAD version of this project, each view would have been drawn separately. In the Revit version, there is no duplication. If I select the footing in the section view, the footing highlights in the plan view. This indicates that the footing in the plan view is not a copy. There is only one instance of the footing in the model. Now I'm going to change the thickness of the footing from 600 millimeters to 300 millimeters. I select the footing, go to the type select, which is on my second monitor, and I select the 300 millimeter footing. There it is. The footing itself is flexed correctly. The tag is updated. And if we look in the plan view, the tag is updated to show the new revised footing thickness. This is not the only change that happens when I change the footing thickness from 600 millimeters to 300 millimeters. The rebar flexes also to suit the new thickness, and the footing schedule updates. In Revit, items on a schedule are linked to those items in the model. I highlight the first row, which is P1021, and look at that. The footing highlights in the model. Now I will repeat the same change I did before. The footing schedule updates. The thickness is now 300 millimeters, the underside elevation changes, and the volume changes from 4.7 cubic meters to 2.35 cubic meters. A mark number is a Revit parameter. The mark number can be used to add a unique identifier to every object in the model. I have added a mark number to every pier, every wall, footing, tie beam, and to each section of steel deck. This unique identifier can then appear in Revit schedules. The view on the left is a plan view of the foundation minus the top slab, showing the mark numbers of the various structural members. Mark numbers cannot be implemented in AutoCAD, since an AutoCAD file is just a collection of lines and geometric shapes. What these lines and shapes represent is unknown to AutoCAD. In an AutoCAD file, the walls shown in this plan view would be simply a series of parallel lines, which is how they would have been drawn. The window on the right shows the wall schedule. Now when I select a wall in the schedule, the wall highlights in the model. If I select wall 412, we can see it highlights in the model. This is a very useful feature. This brings me to the final part of this video, rebar schedules. I have organized the rebar schedules for this project so that each structural member of the foundation has its own rebar schedule. This may seem extravagant, but rebar schedules are just so simple to create, as I will demonstrate. Once the rebar schedule template is set up, each rebar schedule can be populated by using a single query parameter. This is a sheet for one of the piers. Everything you need to know to construct this pier is on this sheet. Here is the rebar schedule. The columns in the rebar schedule fall into two groups. The first group are those columns that contain user input. The second group are those columns that Revit populates. The columns that contain user input are partition, schedule mark, subpartition, and type. Shape is a hybrid column. Sometimes the user inputs the shape. In some cases, though, Revit matches the shape sketched by the user to an existing standard shape that is already in the project. The other columns, rebar number, quantity, bar length, contain data generated by Revit. The bar segment lengths are mostly Revit generated. As I noted earlier, when you select an item on the schedule, the selected item highlights in the model, or in this case, it highlights on the sheet. When I select the anchor pins on the rebar schedule, the anchor pins highlight in the elevation view of the pier, the plan view of the anchor pins, and the isometric view of the anchor pins. This illustrates the fundamental difference between Revit and AutoCAD. The views on a Revit sheet are not copies of views, and the objects within the views are not copies of the object. What you see on a Revit sheet are in fact references to the actual views of the model. In the AutoCAD version of this project, every line and every piece of text on the AutoCAD sheet was stored locally within the AutoCAD file. No XREFs were used. Once the template has been set up, a Revit rebar schedule is simple to produce. Like other schedules, a rebar schedule is a report displaying data in the Revit database. The template consists of the columns to display in the report and the query parameter used to populate the report. This first template creates a standard rebar bending schedule. The query parameter for this rebar schedule is the schedule mark. Here is the empty template. In the Properties palette of the schedule, I select Filter. And there it is. That's a list of all the rebar for wall W601. I'll create another one for a pier. And there it is. There's all the rebar for pier P1001. I'll do one more. This is a list of all the rebar in the B1 layer of the base slab. That's how simple it is. I have created other templates that report the total length of rebar for each diameter. This template reports the total length of rebar for each diameter for the entire project. There are 5 different rebar diameters, and the total length of rebar in this project is 142 kilometers, which is about 88 miles. This template calculates the total length of rebar for each diameter for a partition within the foundation. I labeled as a partition the major components of this foundation, for example, base slab, top slab, walls, piers, etc. As before, I go to Filter, select a value for partition, and Revit will populate the rebar schedule. And there we have the total length of rebar by diameter for the base slab. And now we see the total length of rebar by diameter for the walls. The final rebar template is similar to the previous template, but for this template the query parameter is a subpartition. A subpartition is a division within a partition. For example, in the case of the base slab partition, the subpartitions are the 4 layers of rebar within the base slab. Again, the rebar schedule is populated by selecting a value of subpartition. And there you see the total length of rebar for the base slab T1 layer. I'll do another one. This rebar schedule shows the total length of rebar used for the tie type A in the 1000 by 1000 piers. This concludes part 1 of this series of videos. My experience with Revit 2016 is that construction drawings can be made directly from the model, and thus eliminating the need for CAD programs such as AutoCAD and MicroStation. I hope that you have found this video interesting. If you see skills in this video that your organization could use, please contact me. Thank you for watching.